my name is Tasneem. I'm the senior manager at 98 Percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of, thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th Percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th Percentile. We visited XLR for the campus placement drive and it went very well today. Ms. Ambika, Ms. Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. it was a great experience altogether.
Thank you.
Thank you so much.
From entering into the cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 90th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot, and I experienced a lot of things today. So I'm really hope to be I placed in that company. I'm confident about that. Thank you.
Hey all, welcome you all for this class day 4. Okay, so what we're going to do today, we'll just start it in a couple of minutes. Cool. We're just waiting for a few more people to join. So am I audible? Is my screen visible? Anyone here who have attended all the 3 classes? Yes, like last week's? Great. Okay. It's good to hear. We'll just wait for a few minutes and then we'll start. So today we are just going to discuss on basics of data structure. Just show you how linked list, tag, queue, arrays look like, and then we'll check on the sorting algorithms like bubble sort, insertion sort, selection sort, and merge sort. The logics, and I'll show you the simulation of it, and then post that we'll just show you the program. Okay. Okay, let's just begin. I hope you're able to see my screen clear. I think I are able to see my screen. Yeah, clear. Cool. So let's begin. Welcome you all for this day 4 of basics of programming. So what we learned last day, I think Friday. So we just learned what are algorithms, what is pseudocode, what is the time complexity, what is space complexity. We understood the big O notation, time and space complexity. And we just discussed data structures like arrays, linked list, stack, and queue. I'll just revise these data structures again, and post that we'll go through the sorting algorithms, and I'll make sure you write the code in whichever language you want with the logic, which I'll share. Maybe we'll discuss together and we can share, like we can use C, Python, Java, anything, whichever you wish. Okay. So let's begin. So you can see that this is array. Array means the data is stored in continuous memory, and the array index starts from 0, and the last index will be, if there are n elements, n minus 1. If there are 6 elements, fifth is the 5 is the last index. Okay. Can we mute others? Okay. So I've just prepared this presentation just for your reference. Not necessary that I go through everything, but basically definition: array is a data structure which stores a fixed size ordered collection of elements of the same type. Okay. This is just a syntax of Java where we'll declare how to declare, to initialize it, how to access the elements, how to know the length of the array, how to iterate using normal for loop as well as for each. Okay. That's a single dimensional array. This is a multi-dimensional array, like two-dimensional array where 3 rows, 3 columns kind of thing, right? This dynamic array is Java stuff. Okay, array list, this collection probably will have something similar everywhere. And this sort method is a default method of available in Java. And we'll have sorting, like definitely we'll have array where we can search and sort linear and binary search, which we'll discuss in coming days. Okay. Operations like summation, averaging, sum of things. For example, if you say I have a array of scores, so I want to get the average, I want to get the sum of the scores, so probably we can use these things. Cool. This is just in Java how we define. This is a array with 10 spaces basically. Okay. And you can see here base address. If you say address is 1000 and next address will be 1004, 1008, 1012, so continuous memory allocation will be there for array. Okay. Type is integer. Cool. Now let's come to the second one, which is linked list. I hope I have repeated arrays a lot because it could be sorting or it could be searching. Everywhere arrays are used. Cool. Now coming to linked list. Linked list, there are mainly single linked list, double linked list, circular linked list. So list is basically nodes connected with each other. So there will be head, there will be tail. So in a single linked list, we'll have something like head with the data and pointed to the next list, next node. Then again one more node with the data and pointing to next one. Then 15 is pointing to 20, but then at the end it's not pointing there. It means it's pointing to null. In the single linked list, I can traverse from head to tail, but not reverse. Coming to doubly linked list, there is a head, there is a tail, but still I can go from 5 to 10, 10 to 15, 15 to 20, but I can come back from 20 to 15, 15 to 10. Because it's doubly linked list, it's easy for us to traverse. There comes one more linked list, which is circular. Circular means from head to tail I can go, I can come reverse. Like when I go reach tail, I can come to head from tail. That's a 3 linked list types. Any doubts in linked list? These are the basic interview questions which will be asked, like what are linked list, what are stack, what is queue. All clear, guys? Okay. So this whatever I told, right? It's a linear data structure which are stored in nodes. Each node is having data and link. Okay, they are put in sequence. Arrays have fixed size. Linked list, there is no fixed size. Okay. So this is details which you can go through the PDF, which is, or like presentation which is added in the course. Okay. This is just one more detail. Single linked list, doubly circular. Coming to the basic operation on linked list, what we can do? We can insert, we can delete, we can traverse, we can search, we can update. Insertion, either we can insert at the head or the tail or at the specified position. That's easy. But everything starts from either from head or wherever our pointer is there. Next, deletion. Deleting, okay, how deletion happens in linked list. I'll just show you one example. Let's just wait. Let me share complete one. Okay, can you see my complete screen? Yes. Okay, I think it's visible. Cool. Okay, imagine we have list like this 12 and then 15, and there's one more 10. Okay, and what we can say, if it's a list, a single linked list, it will be connected like this. Okay, and it might be connected like this also, just basically, and this will be connected to null like last one. If I want to insert at second position, what I should do, I should first get the node, then the new node, imagine this is like 25. Okay, then first I should point this to 15. Okay, something like this. So 25 should point to 15, then the 12 should point to this. So this is how linked list insertion happens. Are you clear with this logic? Clear? So this is one of the interview question, like, okay, how do you insert a node in the linked list? That will be the interview question. So you should say that, okay, let's just do control that. So you should be like, okay, we'll take a node and we'll point that to the node where, means if I want to insert at second position, we'll point it to the third position, right? So we'll take it, make sure we point to the third position. Then the first one will point to the newly node, which will be second now. This is a insertion. Clear? No? Not getting this? Okay. So single linked list, at least you understood. I'll show you with the simulation, but generally there is a node and it points to the next node. There is a node and it points to the next node. So this is a single linked list. That much at least you understood? Where? Okay, cool. So if I am adding, I have to take the new node and point it to the node where, the next node where it has to point, right? So basically same thing. The same thing I'm doing here repeatedly. Just think of it. This node points to the second node, current second node, and this becomes the second node. And the first node will point to the new node, which will be the second position, at second position. Okay. Okay. Next thing, if I want to delete anything, then what I'll do? If I want to delete 15, then what I'll do? The node, like 15 is pointing to 10, right? So what I'll do, if I have to remove the 15, then the previous node has to point to the next node first. Then I can delete it easily. This one you got it? Deletion. Let's make it interactive, guys. Folks. Okay. This is basically the linked list insertion and deletion. If I want to insert at the beginning, what I'll do? Imagine this is a new node. There's a new node 32. If I want add to insert at the beginning, what I'll do, every node will have a pointer to the null at the initial stage. What I should do, I should take this and put it behind. That's it. Clear. And now this becomes head and this becomes tail. If I want to insert at the end, just keep it here and this has to point it to the last one. Okay. These things I'll show in a simulation. This is a generic thing. Searching means you'll start from the head and you'll search till the tail. In between, if I get the number, if I want to search 10, I'll start from here. I'll see the data is 12. No, it's not matching. I'll go to the next. I'll see the data is 15. It's not matching. I'll go to the next. Then I'll see 10. If the data matches, yes, cool. We have found the number 10 in a linked list. That's what we are going to check out. Okay. Updating, definitely. If I want to update, I have to go there and update. Cool. These are some advantages, disadvantages. Size can be dynamic. Insertion deletion is easy. There is no allocation of memory, right? The only disadvantage is random access. Random access means even if you want to access, you have to come from head to the point. Not that randomly we cannot access it. That's a disadvantage of linked list. It takes extra memory for references because we have pointers, right? These are the pointers. So that's the extra memory. Next. It's not a cache friendly. This cache thing is a different concept. It's okay, but you can remember for the entry purpose. Okay. Applications are, you can implement stack and queue with linked list. You can have better memory management, graph entries, undo functionality. All these things we can do it in linked list. Okay. Now, third one is stack. Stack, I might have told you, like it's just pile of books, everything. So imagine if I want to add anything onto the stack, it will be top of it. Here, C value is pushed on top of the stack. Previously, B was top, now C became top. If I want to remove, I can remove from the top and next element becomes top. This is a stack data structure. Okay. Only two operations, push, pop. Peek means just show me what is there on the top. Is empty is just to check whether the data like stack is empty or not. The rule of stack is last in, first out, right? So the C is the last which is added, but that's the one which goes out first. So last in, first out, or first in, last out. Okay. So stack we can implement either using arrays or linked list in Java, and there are different mechanisms in some other place also. Use cases is function called evaluation. So postfix, prefix expression, all those things we can use it. Undo mechanism, backtracking algorithm. Backtracking is one of the important algorithm which generally people ask. Okay, there also we can use stack. These are advantages and disadvantages. It's very simple, efficient. Memory management is easy. The only thing is it's not easy to access the inside element. It's only always top element. Memory allocation we have to do dynamically, right? It's memory fragmentation. These are the different things. The major thing is what is stack and how it operates. Okay. These are some applications you can just check out more when you go deeper. Parsing and expression, undoing mechanism, or function call management. Okay. Next. So after linked list stack, we come queue. Queue means first in, first out. The person who is in first will go out. So you just check out here what happened initially. There are two things, either NQ, DQ. NQ means add to the queue, DQ means delete from the queue. So these are the operations which are performed. First, what they did, they NQ'd 10. So 10 was added, then 8, then 12, then 16. So up to 18 they added. Okay. Then what they did, they removed the 10. Okay, remove it. 8, 12. So this is the operations. If you NQ, it will be added at the rear. If you remove, it will be removed from the front. That's a queue. Okay, again, NQ is same as push, pop, whatever similarity. Front or rear. Front means where you will be removed. Rear means somewhere the position where you added your element. Is empty, just checking whether queue is empty or not. Okay. We can either implement using arrays or linked list. major use cases are task scheduling. Task scheduling means the priority task should be at the top, like beginning, so that we finish those tasks and continue with the next ones. Long waiting task, basically. Printing jobs, you see, printing will be done one by one. That's again a queue. BFS, DFS, these are algorithms which we'll learn later. Advantages and disadvantages of queues, like orderly processing, fairness, like it's basically, though, the person who comes first will be served first. Simple. Memory management is dynamic. Again, limited access because in between person you cannot access it. It's only front or rear. Again, dynamic memory allocation has memory fragmentation issue here. Okay. Now, before we come to the algorithms, what I want to check, show you this. So everyone just try to figure out this. Everyone can open this. Let's see here. So let's create a linked list with 5 items. Okay, random numbers, but these are not sorted. Okay, just check head and tail. Head is at the beginning and tail is at the end. Tail is pointing to nowhere, but head is pointing to the next element and like consecutive numbers. So let's just start empty one. So imagine this is a empty linked list. Okay, if I want to insert at the head number 40, see this all simulation you can see at the beginning as linked list was empty. Now the linked list is having only one. Okay. Now every linked list has either head or tail. That's clear. When there is only one element, that itself becomes head and that becomes tail. Okay, and both are pointing to null because there is no element after it. Okay, next if I want to insert one more 30, so it will come after 40. Let's see this. Just I'm inserting. Okay, oh sorry, it becomes the head. I'm adding at the beginning. Okay, so I can just check out the change also. It's up to me where I want to add. If I want to, this one, see, inserting at the head, inserting at the tail. So imagine if I want to insert at the tail, then it comes after this. Can see this head and tail. Next, if I want to insert something at some position, let's say insert at first index number 60. So what happens? It has to come after 30. Just check this. Okay, see, I have shown you this now. Clear? Same thing. We'll just repeat. Try to do the same thing. Like at the index second, I'll try to insert 35. Okay, so it has to come between 60 and 40. Let's see what happens. Correct? You saw that? Are you getting this? Who is understanding this? Linked list. Okay, good. Anyone else who is getting this? What's happening in linked list? Okay, no responses. Cool. So let's try to remove one. So okay, there are only things: search, insert, remove. Let's say if I want to remove head, then this will be removed and next item becomes head. 60 becomes head now. Let me remove the head. See, I removed and the code runs like this. Next, again remove head. This, in case if I want to remove tail, then 40 becomes tail now. Clear? Let's try to create 8 random but sorted. Okay, imagine if I want to remove 76, what should I do? I should remove at the 4th position. So let's say this, remove at the 4th position. So what happens? It removes 81 but connects 76 with 84. Let's see this. It's coming from 1, 2, 3, 4. Okay. This is the item to be deleted. Look here. Did you understand? Did you get this simulation? Cool. So, okay, just help me. If I want to remove 36, what should happen? Can you quickly answer here? "36, if I want to remove, what should happen?" It has to make 17.76, right? Let's just quickly see that. Okay. The position 3. Just check here. Started from 12. It went to 17. Again, it went to 36. 76. Then pointed here. Third position. See, it starts from 0. Head means 0. Tail means last but 1. Means 6. If there are 6, it will be 5. Okay. So basically, this is linked list. If I want to search some number like 88, check here how it works. It goes one by one. It checks the data here. See here. It says, okay, fine. It found search 88. If I want to search something like, it will go till end and it will fail. See what it's trying to do. Is not found on the linked list. Okay. This is basic linked list. So linked list has things like the node has data and pointer to the next node. Everything starts from head and tail. If there are no elements, head and tail are null. If there is only one element, head and tail both are null. If there are n elements, head is there and tail is there. Tail is pointing to null, head is pointing to the next element. This is basic concept of linked list. Okay. Let's say about stack. So you see here, items are inserted one above other. So 88 is inserted first, and then 82, then 36, then 14. So if I push something, then it goes above that, and that becomes the top. See here. Again, try that. If I push something, that becomes the top stack. If I just do a peek, and it will return me what's the value on the top. If I try to do pop, it removes the top element. How many elements I want? I just want to remove one. Okay. It removed the one from in the top, and it next element it made as the current top, basically head in this. Okay. Let's see now. Let me try to remove 3 elements. 1, 2, 3. Okay. There are only 3 operations, either push, pop, or peek. Pop means which removes that from the top. Push means which adds to the top. Okay. Peek means which will just retrieve which element is in the top. That's it. Cool. Understood? 17.26. Okay. Show question. Show Q. Okay. I didn't get FIFA. Okay, let's just see Q. Q means what? Let's just create 6. Okay. Those who like the one which is inserted first will be removed first. Let's just dq means delete. If I want to remove one, then see it removes from the first one. Again dq. If I want to remove two, first it removes the one which is at the first head and then next one. Okay. NQ means append at the bottom, which means after tail it will come. See, 78 will point to 12. That's the queue. Okay, let's just create empty queue and try now. Random. Let's just try to follow this. Let's see. This one. Okay, let's NQ 10, 8, 12, 16, 9, 20, 30, 18, something like that. Let's say 10. NQ 10. You see, that's created. Next, 8. Add NQ. So it will be the pointing next one. 8. Let's say 12. Correct? So first in, first out. If I want to add, it will be added at the tail end. If I want to remove, it will be removed from the starting point. Basically, head end. See, head will be removed and next element becomes head. Basically, this is linked list, stack and queue. Doubly linked list means both are pointing. I can either insert at any position or insert at place or remove at. If I just remove head, then it will become like this. If I remove at some position, so imagine if I remove at second index, this is how it becomes. 93 will point to 79 and 79 again will point back to 93. Okay. If we want to remove middle, then we have to use multiple stacks. Okay, I'll show you that. But generally, removing from the middle is not possible directly. So what we should do, I'll just show you what happens. So imagine we have okay, stack. Just imagine this. Okay, 2 is there, then 3, then 4, then 5, then 6. Okay. If I want to remove 4, what we should do is we should get one more stack where I should put 2, then on top of it I should put 3, popping from here. Okay, that's a basic thing. Pop, then remove 4, then get push 3 here, then push 2 above it. This is the generic way of doing. If I want to remove from stack. Got that? Okay, great. Okay, so this is doubly linked list where head is pointing to the next one, and then again, like even the reverse can happen. The next pointer can point back to head. Double-ended queue, same way, but it will work like a queue. Either I can remove from head or remove from tail. That's it. Okay. It's up to us how we traverse, but generally queue means adding at the end, remove from the beginning. But still, if you want to remove also, because we are able to traverse easily using 2 pointers, it's easy to delete from anywhere. Okay. Anything here in this data structures? I have written code, can go through that maybe later. Okay. Queues and all. But this is mostly in Java. Traversing. Where? Traversing in? If it is in stack. Okay. You are wherever you are traversing, the one thing you should remember which pointer you have. If you are aware about head, then only you can traverse from head to tail in linked list. Stack from head till tail means just traverse through it. Simple. Queue, again same thing. Head to tail. Doubly linked list, you can traverse from both the ways. Double-ended queue, again both the ways. Okay. Any questions on this? No queries? Okay. Okay, cool. Anyone from YouTube? So basically, if you go through with any programming language, right, you can implement this. The only thing is they'll ask the questions. Okay, just they'll ask you like, okay, show me the implementation of linked list, the logical thinking, how the linked list is done, how the stack is done, how the queue is done, push operation or pop operation, how we can do, how we can add in the linked list, how we can remove from linked list. All these things are generic questions. You just need to tell the logic and then try to use your basic programming skills and come out with some answers. Okay, that's the expectation. You people can try this. So if there are any queries, okay, not getting. I'm hearing that Madhavi is saying not getting. Okay. Fine, but still, just try to understand what is linked list, how it is structured, what are the operations we can do. Okay, head, tail, insert at the head, insert at the tail, insert in middle. Three operations. Delete from the head, delete from the tail, delete in the middle. Three operations. This is the major operation. Add, insert, delete. Update. Okay. Okay, let's just take 5 minutes break and then we'll start with sorting thing. I'll just show you with the example and then show you the code. And later, if you people are interested, you can explore that in any language. I'll share you the code snippets also. Let's take 5 minutes break. Any queries, just post it here. So cool. So we are back. I could see that people are saying not audible. Okay, we just took a break, guys. Every one of you, just do me a favor. Just go to Google and check. Try to check like something like most asked questions on linked list, most asked interview questions stack and queue. Okay, then you'll majorly get it like uh, show me a linked list using stack or create a stack using linked list, something like that. Okay, so now we are just going to check out on the sorting things. Okay, just see if fitting. Okay, so are you able to see this simulation page? Yes, can you see? Okay, can you see the screen? I believe yes. Clear. See, these are the interview questions which are asked generally on sorting. Okay, selection sort, insertion sort, merge sort, bubble sort. Can you hear me? Audible or not? Okay, so till like last week we have understood bubble sort. Bubble sort means what? It takes the largest element and keeps it at the last. Let's just check here. This example. Okay, so what it does, it compares 47 45, it swapped, then 47 45 15 swap, then next swap. So it takes the largest element and keeps takes it to the last. This you understood previously? Anyone who remembers this? And then what it does, after this, at the ninth index, the array is sorted. But again, it comes back at the beginning. Then again, it compares two. So you see here, there are two operations. One is comparison, second is swapping. This if logic, this is comparison, this is swapping. So both are time consuming. Okay. So every time we are swapping, comparing, swapping, comparing, swapping, comparing, swapping, comparing, swapping, comparing, swapping, compare, swap. Okay. Again, same thing happens. The only swap, it will not swap only if the number is lesser than next number. So it goes on like this. At the end, you can see that there are lot of swapping and lot of comparison. That is why the time complexity of bubble sort is, what is the time complexity? Can someone answer here? What is the time complexity of this? N square, correct. Cool. Now, as this is very basic thing, what it did, logic is, okay, everyone will ask you to write a pseudocode. Pseudocode means what you should say? It does two iteration. On every iteration, it compares the like adjacent elements. Then if the left element is greater than the right element, they swap. Okay, and the iteration continues until there are no more unsorted values. So for every iteration, the last element, like if there are at the first iteration, last element is the sorted one. Second iteration, two elements. Third iteration, three elements. Fourth iteration, last four elements, like this. Okay. Now coming to selection sort. Okay, let me tell you the logic of selection sort. Okay, what selection sort does, it selects the minimum number and puts it to the beginning. Okay, let's just check this. So here it is traversing through the array. It's just checking which is the smallest element there. So the smallest element is 15. So as the smallest element it's 15 and we have the 15 at the index 0, so we are not swapping it or not doing anything. Then again next I went like this. Again it's checking out the remaining elements, and then it realized 15 is the smallest element in the remaining part of it. Okay, then it swapped with the first index. Let's just check next one. Here what happens, 16 becomes the smallest element in the remaining legs from second index to 19 index. Then when after iterating till end, when they know that 16 is the smallest element, they swap with second one. Just observe here, they are not doing swapping, they're just doing the comparisons and they're getting the smallest element. Selection sort means select the smallest element and keep it at the right position. Okay, check here. Checking out 16 now becomes smallest, right? 16 is swapped with 49. Same way. Now 25 becomes smallest, it's swapped with 27. Goes on like this. This is the selection sort. At the end, the whole array becomes sorted one. So let's just check out this. You people just check here. Okay, I want answers. Okay, let's do selection sort. Let's take this as an example. Okay. Now, iteration 1. What we are doing, we have to select the smallest element here. So what we do, we compare 64 with 34, then 34 becomes smallest element. So let's just keep smallest element at this iteration. Now it is 34. Next, we compare 34 by 25. Again, we got 25 as the new smallest element. 25 with 12, 12 as the new smallest element. 12 is compared with 22. No. Then again, 12 is compared with 11. Yes, 11 is the smallest element. 90 is compared with 11. No. Right? At this point, the first index is swapped with the smallest element. So what we do? We make it 11, then 34, then 25, then 12, then 22, then 64, then 90. Right? Let's just try to check after first iteration what happens here. Let's just say create one. Okay. See here. What happened? Between 0 to 50. Okay, they're expecting 0 to 50. Let's make it then 44, then make it 50. Okay, now let's just sort it. First iteration, what happens? So 44, 34 compared, now 34 becomes the smallest element. Next, 34 and 25 compared, 25 becomes smallest element. 25 and 12 are compared, now 12 is the smallest element. 12 and 22 compared, now again 12 remains the smallest element. Now 12 and 11 are compared, what happens? Now 11 becomes the smallest element. 11, 50 compared, still 11 is the smallest element. So now at the first iteration, we are going to swap 11 with 44. So what happens? Correct. So after every iteration, see here, this part is sorted and this part is unsorted. Clear with this? Selection sort logic. Oh, so soon. Okay, let's just say then. What happens in this iteration? Next iteration, what will be the sorted and what will be the unsorted? Quickly answer here. This is selection sort. Answer guys, what will be the next element after this? Okay, no worries. What happens when, see, this is the first iteration, means I is 0. So when I becomes 1, okay, that time only this part of the unsorted array will be traversed. When I traverse through this, now what happens? Here, smallest element is 12. Okay. When I compare these two, 25 smallest and 25, 12, 12 is smallest, and 22, 12, 12 is smallest, 64 with 12, 12 is smallest, 90 with 12, that is smallest. So at the second iteration, our sorted array becomes 11, 12, and this 34 is replaced at 12 position. Okay, let's just check this if this is going to happen at the iteration 2. Someone 12, okay, cool. Nice, someone is responding. Just see the second iteration, okay? 34 goes to the 12th position. Just check out the position, okay? Clear? Okay. What happened to the third iteration then? When I is 2, what is the smallest one? In this part, 22 is smallest, and 22 is replaced with beginning. So when I put 25 at the third value, then 25 is replaced in the 22nd position. This is how the array becomes. Let's see that. See? Swap it. So if you see the logic here, the okay. So basically this is how it is. So every iteration, next iteration again, what happens? 25 becomes the smallest and again sorted with 34. Then 34, nothing. Everything is sorted by now. Now nothing, no swapping happens. Right? This is a selection sort. Selection sort means there are two things. Left side is the sorted one, right side is unsorted. At the beginning, left side there are 0 element, nothing is sorted. At the end, it will be like this. So each iteration, left side will get a sorted subset, sub array basically. At the first iteration, there will be 1 element, second iteration, 2 element, like this. N iterations, N elements. Okay? Any doubts in this selection sort? Any queries? Okay. Any queries here? Selection sort? If no, we'll go to next one, which is insertion sort. Descending order, we have to reverse it. The logic should be reversed. That's it. Greater than, instead of greater than, we have to make it largest element. Get the largest element and put it here. I'll show you in the code. Okay, let's just run this. Okay, I'll show you and I'll run and show. The same logic is applying here. Okay, 1222. If I do this, see? Are you able to see that? Instead of minimum, I'm getting the maximum number. Got it? You can just check this. So when comparing, I'm just going to search for the maximum element in the remaining part. Then what happens? Even if I see this, let me just see here. Okay. It's only take 4 elements for timing because we want to save the time. So what happens at the 0th? Largest element is 34. I'm going to swap with 0th index. 34 is here and unsorted becomes 14, 25, then 12. Next iteration. In remaining 25 is the largest. 25 is sorted with 14. So what is this? 34 and then 25 and swap with the element 14. Next, it's all done. So next iteration, no swapping happens, only comparison. At the end, 25, 34, 25, 14, 12. The only logic is the simple. Instead of checking out the smallest number, I am going to find the largest number. Clear or not? You can just try this code. I'll give you the GitHub thing if you want. Just check out this. Day 4. You'll get it. Okay. Any questions on the selection sort? Or do you have any number which you want to check out here? Creating custom one within 50? No queries? Okay, so then let's go to the next sort, which is insertion sort. Okay, just a quick recap. Bubble sort means it compares the consecutive numbers until I go and put the largest element at the last. If the consecutive numbers like next numbers or the numbers which are side by side are greater, they'll be swapped. Okay, just I'll show you again. Okay, so you can just check here 20, 35, it will not swap. 35, every time it will swap. Every time, whenever the number which is greater will be swapped, irrespective of whether that will be the largest or not. Okay, here also just check it. 35, 43, 43 is swapped, 1 is swapped, 4 is swapped, like this. Swapping happens wherever you find the previous element is larger than the next element in the bubble sort. What happens in the selection? Selection sort, initially the left part is considered as completely sorted where 0 elements are there. Then it iterates through complete array and it gets the smallest element and puts it replaced with 0th index. So here what happens? The element at the 7th index will be replaced with 0th. So 13 will go here, 6 will come here. Just check it out. Okay. Next, again 24 will go to this index and 6 will come there. Okay. Same way. Now 13 will come to 37. Just check that how it's happening. Same way the sorting happens. Only comparison is done, swapping is done only once in a iteration. But in bubble sort, every time if they see the number is bigger, they swap. Okay, both are clear? Yes. What's the difference sorting and bubble sorting swaps every time. Selection sorting only swaps at the end. It's not going to swap anywhere. You can try simulation, you'll get it. Okay. Selection sort means select the smallest element and put it in the sorted part of it. Clear? Every time, part by part, we start sorting. Now, let's see insertion sort. What happens in the insertion sort? Just check it out. You people can just see and then let me know what's going on here. Are you getting this? Who understood? Who got this simulation? Anyone from YouTube? Sorry. Who is here? Who understood this simulation? Insertion sort. What happened there? What exactly logic happened here? What was happening in this insertion sort? Just check this fourth thing. Okay, I cannot do this. No? Okay, playing card game. Okay, cool. Let's just check out the insertion sort thing. Okay, I'll just try it out here. We have 23, we have 22, we have 12, we have 15, we have 16, we have 42, we have 32, we have 12. Now, like, let's say 6, 18, 17. What happens at the insertion sort is there will be again two things. It will also have sorted and unsorted part. Okay, at the beginning, what it considers as the left side as sorted, right side as unsorted. At the beginning, what has completely it is unsorted. But at the first iteration, what it assumes it takes the only one element. It says, okay, now it is sorted, boss. Okay. If you really look at this number, then definitely it is sorted. Correct? Next, what it does, it takes this number, 22 number, and it tries to compare with 23 or insert. Okay. Selection means I was selecting the smallest element and putting at the beginning. Insertion means take the next element, insert it at its position. Okay, what I'm doing, I'm taking 22 and I'm checking what is the position in the sorted array. What's the position of 22 in the sorted array? So when I take 22, I see that it comes at the beginning. So what I'll do in the next iteration, I'll take 22 and I'll put it at its position. It's a before 23, right? Next, what happens? This is sorted and this is unsorted. Next step, what I'll do, I'll take the next element. I'll see where to insert this. When I saw that, okay, it is lesser than 23. Again, I compare it 22. Again, it's lesser than 22. I take it and I put it in this position. In the next one. Okay. In the next iteration, I keep this 22 at the beginning. Again, next what I do, I compare 15 is 23. I see that 15 is smaller, so I swap that. I put now what happens next? 15 comes here and 23 goes here. Then again I compare 15 and 22. Again 15 goes here, 22 comes here. At this point, this is sorted part. The same way, 16 is after 15, 42 is after 23. So it keeps on happening. Okay. The main goal of the insertion sorted, take the element and insert it at its position. So 16 should come after 15, but before 22. So in this sorted part, remaining items are taken like that and sorted. Okay, let's just take this only and see. I'll just show you. Okay, what was the question? Yeah, it does not go beyond because the left part is already sorted. So it doesn't need to compare it, correct? Let's just check it out. Okay. What? Okay, hold on. Insertion sort, create, just creating it. 50. I need to put comma. Sorry. Okay. You can just observe what happens here. 22 is swapped. See this swapping happens and again swapping happens at kept. Swap, swap, and put the 15 in its position. For 16, again come back. See, you have to observe what this index 3, 4. They are shifted to the next index until unless they get the proper index. At this point, 42 is not more, but 32 comes. 42 goes at the sixth part. Yeah, see this. 17 will come till this. Yeah, swapping is happening here. Move sorted element to the right. See here, moving. Swapping is happening basically. Swap or move. Getting it? Did you understand this part? Selection sort and insertion sort. Got it. Clear. Selection means select the smallest element, put it at the beginning. I mean, at the end of the sorted part. Insertion means take the element, insert it in the right position. That's it. Bubble sort means just sort the and keep it the largest element at the end. Okay. Now there is a fourth sort called as merge sort. Okay. But for merge sort, what I want is I want to show you this. Who is unmuting themselves? Okay. So merge sort is basically divide it into half until there remains only one element. Okay. So you see here 6, 5, 12, 10, 9, 1. It's divided into 6, 5, 12, 10, 9, 1. Again, because there are more than one element here, it's divided into two subparts. 6 and 5, 12. Here when it comes to 6, it's a one element. So no need to worry. Then again it goes to the second part, 5, 12. There again more than one. Divide them, 5 and 12. Okay, go here, 10. 9, 1. Again divide. So when at the iteration where there are only one element, they are compared with the next element. So in the next iteration, 5 and 12 are compared. So they are already sorted. They are merged there now. Till here it's division, then it's merging. So 5, 12 was merged. Cool. Then 5, 12 compared with 6. So now 6 should be put after 5. Like it's 5, 6, 12. That is done. This part. Now it's coming here. 10, 9, 1. 9, 1. When I compare 9 with 1, I have to sort it. So first should come, 1 should come first, 9 should go the next place. So 1 and 9, okay. Then 10 is compared with 1 and 9. Just take 10, compare with 1, okay. It is greater. So 1 will come first, again compare 10 with 9, it is greater, 10 will go after 9, right? So when you come down, you see this part is sorted, this is sorted. Now merge it. So when you are merging and comparing with 5 with 1, okay, I saw that 1 is smallest one, keep it at this part. Compare 5 with 9, 5 is small, keep here. Next, go to 6, 6 with 9, 6 is smaller, you kept it here. Compare 12 with 9, no, 9 is smaller, 9 is kept in the next index. Compare 12 with 10, 10 is smaller, 10 is kept in the next index. then compare 12 with, no, 12 is the last, so it is merged. So divide and then merge. Divide until we get only one element, then merge according to their sorting criteria. Okay, that is about merge sort. Just let's see how the simulation happens. You can just see here. Keep on dividing and then we'll check it. Here it's not clear. It's okay. Oh, it's merge sort. Merge sort. You see, this is left part. This is the right part. Okay, we will not understand this by this way, but whatever I explained here is understood or not? Yeah, n iteration less log n for comparison, correct? Okay, cool. What about merge sort? Okay, let's just check it out. I'll just again do a revision kind of thing, then show you the code in the Java part. Okay. Okay. Bubble sort. Small example. First pass, second pass, third pass. In the first pass, 7, 6 are compared, swapped. 7, 4 is compared, swapped. 7, 3 is compared, swapped. At the first iteration, 7 is sorted. Then come here. 6, 4 is compared, swapped. 6, 3 is compared, swapped. Then 6, 7 is sorted. Then third pass. 4, 3 is sorted. This is the basic bubble sort. Okay. No. So this is about bubble sort. Bubble sort is just a simple sorting algorithm which does repeatedly, compares adjacent elements and swaps them. This is like the brute force algorithm kind of thing. Again, the theory, whichever I explained here. If you want to go through, you can go through that in the presentation shared. Okay. The only thing is the worst case, whatever it is, it's big O of n square. Okay. Because it compares and there is a chance that it swaps. That's why it's n square. Space it doesn't take because it's just doing in place sorting. So you can just think of in place sorting. Okay. Next, selection sort. The minimum element is selected and kept at first step for 0th index. So this part is sorted array. This is unsorted array. Second time, the minimum element is selected and kept in the second position of the sorted array. Then unsorted array. Same way it goes. You can just check this. Ultimately, left part will be sorted array, right part will be unsorted array. Okay, it's just like moving a card. These are the steps. You people can again try it. This will help you explain in the interview. So what you will do? What are the steps? So we'll select the minimum, move to the first unsorted, like swap with the unsorted element. Clear. Okay. Time complexity is the n square for the worst. Average is also n square here. Best is also n square. Insertion sort. You can just see here. The element is inserted at its position. So 4, 3, if you see, 3 is inserted at this position, 2 is inserted here. 10 and 12 are greater than this 4. There is no swapping. 1 is swapped here. But consecutively, they are swapped and inserted at this point. 5 is here, coming here, 6 is coming here. But whenever I find this element which has to be inserted, there will be swaps, so many swaps. Okay. So where insertion sort is useful? Definitely where you have the almost sorted data. So you might be hearing like big data and all, right? So when you have almost like sorted elements, so you can use this sorted array basically, okay, or partially sorted. It is stable because it preserves the order. See, this is again first element in the array is considered as sorted initial state. Then insertion happens based on the position of the element. We repeat until we get the array sorted. Complexity worst case is n square, best case is n because everything is sorted. Then everything it's n only because I'm not going to swap. Average case is n square. There's no everything it's in place, so big of n. Merge sort. Merge sort you can see divide until you get only one element, then merge them in a sorted order, then again merge them in a sorted order. Okay, this is just stability, efficiency in terms of like where there's a large data sets, it's less efficient. It's really good in like large data sets. If you have small data sets, it may not be efficient. Okay, this is again the array is unsorted. Divide it recursively. Recursion we can teach in the next class. Recursion, what is recursion? Divide it until you reach an array with one element. Then merge them until you get everything sorted out. Okay. Divide, merge. Cool. The time complexity is n log n, even at the worst case, best case, average case. Because merging takes less time because we're just putting it the right position. Okay. Division is log n. Cool. Yes. So instead of rather than questions, right? Just let me just share this thing. See, this is Wikipedia. You can just check out. Look here. So many are there. Merge sort, heap sort, intro sort, tree sort, block sort, smooth. So many team sort, patient sort. There are so many algorithms and everything. Best case, average case, worst case, memory is stable. Everything is there. You people can just check out this. There are so many if you are interested. Okay. There's some bucket sort, counting sort, radix sort. Lot many sorts are there which are used in our real time. Now I already shared the code. If you want, I'll just run this now. If you want, I can just run and show while debugging. How I'll debug, you know, right? I'll put a debugger here. I can debug it easily. So if you people are interested, I'll show the debugging. Otherwise, we'll keep the next things for Q&A. But trust me, sorting is one of the important interview question. So what we learned today? Okay, show code. Okay, I'll take 2 minutes break, then I'll have water and come. Okay. But meanwhile, you can just check the GitHub. I'll show you the code. Hello. So we have already seen the bubble sort. Let's just go with the next one, okay? Okay, those who have joined just now, can you help me understand what we did till now? Okay, sorting terminology is really required. Okay, okay. Let's just go with selection sort. I'll show you. Can you give me a set of numbers, Afifa or someone? We'll try with those numbers rather than these numbers. Okay, and then you only will get the idea. Quickly, ping in here. Hello, can you hear me? Or is my screen visible or not? Can just check this. Okay, cool. Let's just do this. You've given me the sorted one. Why? Okay, I'll say shuffle it. 9, 44. Okay. Now, the sorted order is reverse. Clear? What happens when we come here? I'll just show you. Okay. Am I audible? Can you hear me? Yes or no? Okay. So next, straight we came here. At the beginning, we thought, okay, 0 is the minimum index. We start comparing. Just see here. Add self minimum index becomes j, which means 88. Yes, clear. That's okay. Next time, see now 9 became the smallest one. Okay, and then 8 becomes at the end, 8 becomes smallest. So we are trying to swap it. Let's just see here what becomes. What is the array now? If you look at the array is 8, 9, 45, 66, 88. So we'll start from 9 now. Till 8, it is sorted. Okay. Next, what we do? Went on. Started comparing. And then at the end, what was the minimum index? Minimum index was 1 only, which means in 9, 45, 66, 88, 9 was the smallest. Even we swap also, it will be same only because min index and I are same. So at the end of this loop, 8, 9, 45, 66, 88. Okay, again, oh. If we repeat this, it will happen same way. Wait, I'll use the number which you give. Okay, can show you rather like this. Okay. Okay, now array is 88, 66, 45, 6, 8, 9. So what I do, I iterate through, and at the beginning, what I assume whatever I, that is the minimum index. Like according to me, 88 is minimum because I have to start comparing. Then I'll start comparing. When I see that 88 is greater than 66, now 66 becomes minimum index at this point. Then again I'll compare 66 with 45, then 45 with 6. Then I see that 6 is minimum. So value at this index is minimum. So it goes on. Next 8, 9 are greater than this. So minimum index will be still 3. Just check this. At the end, minimum index is 3 only, which means 6. And we are swapping 88 with 6. Just check it. So that the same way now in 66, 45, 88, 89, 8 is minimum. We'll swap that 8 with next, like first unsorted part, which is 66. Okay, just check this. Now you got this. Next would be 9. Check it. Done. Next would be 45. Next 66, 88 are sorted. This is it. See? Sorted part. Understood? Did you get this or not? Got it. Great. So we'll try insertion sort. Insertion sort means take the element, insert it into correct position. Okay, let's just debug this only. So what I'll do, I'll start debugging here. Check this. So initially we assume the first part is sorted, correct? Then in this part, we take 34 and put it in 64th place. Check it. Now the array is 34, 64, 25, 12, 22, 11, 19. So according to us, 34 and 64 are sorted part. 25, 12, 22, 11, 90 are unsorted. Now we have to put 24 in this 34, 64 so that it goes in the right part position. It's inserting in the right index. So 64 will come in 25th position, 35 will come in 65th position, 25 will go in 34. Let's just see this. You can just observe how it happens. Keep changing. See array, you see the array? Now 64 came in that, 25 is swapped. Now 25 goes in the first one. See? Now 25, 34, 64 is the sorted part. Remaining is unsorted. Check this code. Ultimately, at the end, 22, 12. Clear? Now, everything is sorted, but it will run till end. Now, at the end, you see 11, 12, 22. It's a sorted array. It is in place sorting, which means in the same array, we are sorting it. Got it? The logic is very simple. Take the element, swap it until you reach the right position. Correct? Let's just take it here. Okay. I'll just take small 2. Okay, let's take very small one. 4, 8. Okay. And so total, let's make it 1. So in the insertion sort, we assume the first element is sorted. Okay, cool. So we come here. We take 8. We compare 8 with 4. Yes. 8 is greater than 4. We don't worry about it. Next we go here 5. We compare 5 with 8. Yes. 5 is smaller. So what we do? We swap it like this and we put it. Next I compare 5 with 4. No. 5 is greater. Will not worry. So 4, 5 is sorted. 8 is sorted. Now we come to 1. We compare 1 with 8. 1 is bigger. So I go here and I put it in this place. Again, compare 1 with 5. I swap it. Then I compare 1 with 4. Then I swap it. This is insertion sort. Okay. Any doubts? Any doubts? Okay, let's just put a quiz kind of thing with you all. I'll create something like this. 25, 34, 2, 3, 4. Okay. And 12. Okay. Can you help me with the insertion sort here order? Let me put side by side. Anyone here? Okay. Anyone in the chat can respond. Where is this chat? No, you are giving me sorted order. I don't want sorted order. What I want. Right. Hmm. Okay, I can't do this. Okay. So the only thing I want is okay. First iteration, 25 is sorted one. What happens when it comes to 34? What it does in the insertion sort? Do we sort it? No. When it comes to the two, what we do? Tell me the steps. At least put out the steps like this. Sort it means okay. Swap it. Get it here. Move it to this index. Come here. Then again compare. Go here. Move to the next index. Right. So the three are sorted. Now again, when we come to the third index, 0, 1, 2, 3, we compare 4 with 34. Yes, 4 is small. And move it to the next index. Compare 4 with 25. Yes, 4 is smaller. Again, move it to the next index. Compare 4 with 2. Yes, 4 is greater, so we are not swapping. Again, come to the next part. Till 4 elements is sorted. Again, we do the same thing. Sort it, keep it here. Compare 25 with 12. Sort it. I mean, swap it, put it here. 12 and 4 are already sorted, so this part is sorted. Next, compare 3 with 34. Get it here. 34 will go last. 3 will come here. 25, again 25 will go to the next person. 3 will be swapped. Again 3 will be swapped with 12. 12 will go to the next person. This is the insertion sort. Okay. Yes. Yeah. Generally, insertion sort means in take the element and put it into its position in the sorted part of the array. Selection sort means take the minimum element and put it in the at the end of the newly sorted array. Because newly sorted array, it means whichever is newly sorted in the unsorted array, the number will always be greater than the sorted array. So we have to put at the last only, or at the beginning of unsorted array we have to put. Any queries you have, or do you want to try this in your editor and see? Okay, let me just wait. I wanted to check out some lead code problems for you all. Can someone solve these things? Can you try solving these problems? Just sharing, okay? It's 1967 or 1859 sorting the sequence this thing. Can anyone try this? I've shared the link. Can someone try this? I have the answers also. If you want, I'll show you that. This very easy answer. And this is also there. Oh, no. Okay, lead code definitely will have a lot of things. See here, you'll get to know who asked like Facebook, Amazon, Bloomberg, TikTok, Google, Apple, Microsoft. These are the companies which are asking all these questions. Okay, and you can go here and select whatever you want. Let's say sorting. You just see the sorting here. See merge sort, there are 11 questions. Sort. Topological, counting sort, radix sort, bucket. There are so many sort. Even just normal sort also. There are a lot of things. See here. Okay. Anyone have any queries? Any queries, folks, on this sorting? Where the logics understood by you all? Hello. Did you get the logics? Bubble sort, selection sort, insertion sort, merge sort. Merge sort I had to show, right? Okay, hold on. Let me just share that last one. Merge sort. This is a recursion. It keeps on dividing. I can explain you tomorrow when I explain recursion maybe, but still try to understand. It keeps on dividing until unless I get a element which is only one, then I'll merge. So it keeps on dividing and then merge when there is only one element. And then on top of it, the recursion happens. You can just check this. Not getting. Okay. Any other queries? Try solving some lead code problems. Okay. Attendance links, attendance. I think it's already shared. Any queries, folks? Those who have just now joined, they also can ask. Okay, those people who are responding, I think Afifa, Akshay, 2 people responded. Did you get, guys? Adit, Snehal, sorting? Okay, thank you. So can you actually tell me logics for this sorting? Basic logics. Like what is the difference between selection sort and insertion sort, merge sort, bubble sort? Yeah, it takes a lot of time. I understand it's not that easy to get at the first point, but still, sorting is something which is used in big amount of data also. Like there are places where we need efficient sorting algorithms. Otherwise, we cannot handle large amount of data. Akshay, FIFA. Okay, every sorting depends on data, how data is given. Okay. Okay. What is selection sort, Akshay? What is insertion sort? Afifa, if you are there. Yes, in bubble sort it's okay, cool. Next, selection sort and insertion sort. The code, I'm just sharing the code, you can just take it. So, oh, wait, I need to remove the package. Can just check the logic. If you get that, I'm good. Okay. Bubble sort and insertion sort. First, I'll it's compare, then merge, divide, and conquer. Okay. It will compare, then swap, repeatedly selecting small elements. Okay. Okay. Good. Great. Okay. Try practicing. If you really want the program in different programming language, just let me know. I'll share it in the GitHub. Which other language you want other than Java? I can write the code and share it. Just let me know tomorrow. HTML. In HTML, what we can do? Like how we can write the sorting in HTML? Sorting is a programming thing, right? Adit, Python. Okay, I'll give in Python. Then okay. Anyone from YouTube? Anyone has any queries? There are no queries. We can just wind it up for today, and tomorrow we'll be learning next set of programming programs basically. Okay. We'll have a divide and conquer, we'll have backtracking, we'll have everything. But basic logical thinking. Coding and all maybe in subsequent in a deeper analysis whenever we go through some program language, then we'll learn. Okay. Yeah. Thank you guys. If anything is there, I'll be here for a few minutes. You can ask me. Okay, then as there are no more questions, thank you. See you tomorrow. See you on the same time. Cool. Thanks a lot.
Yeah, thank you all. I hope there is no any query or question. So we'll meet you on tomorrow.